welcome back to Ask IITians. In the previous lecture, I told you what do we mean by system, surrounding and the basic parts of thermodynamics. So in today's lecture, I'll be telling you what are the different kinds of processes which are associated with thermodynamics. We'll try to discuss about different kind of processes including adiabatic, isothermal, isochoric process. So let's start with the session so that you can understand the different kind of processes. Now moving over to another topic, let us start discussing something about thermodynamic processes. Now as per I have told you in the very first slide that once we are done with something which is known as system, surroundings and boundary, we'll come over to what do we mean by the term thermodynamic processes. So let me first of all define what do we mean by a process, and I will simply say that any path along which the state of the system changes is known as a process. Now, to define what do we mean by a process, we should know first of all what do we mean by the state of a system. Let's take into consideration, for example, you have a beaker in which you have kept some water. Now, you have enclosed this beaker with a piston arrangement. That means you can either move the piston up or you can move the piston little down. Now, what are the pressure, volume and the temperatures of this system as a whole at any particular point of time? This is what is known as state of the system. Now, we know what is the state of the system. So, this is at, for example, time t1. Now, let me do a process over the system like I am trying to push the piston little downwards. Now, if I am trying to push the piston little downwards, that means the system is going to change from state 1 to state 2. So, this path along which the state of the system has got changed, this is known as a process. Now, once we know what do we mean by the term process, we can define what are the different kind of processes which we are going to study in thermodynamics. So, the first process that we are going to study in thermodynamics is known as isothermal process. Now, iso means same, and isothermal, since it is comprised of two words, so iso means same and thermal means temperature. So, those processes which take place at constant temperature, like for example, I am trying to move the system from, let's say, a state P1, volume V1, temperature T1, to I am trying to move it to another state where, let's say, the pressure is P2, volume is V2 and temperature is T1. So, during this process, the temperature of the system didn't change, and hence this kind of process is known as isothermal process. Let's move ahead to another type of process which is known as isobaric process. Again, I'll say iso means same and baric, since bar is a unit of pressure. So, any process which takes place at constant pressure, let's say for example, I'm moving from pressure P1, volume V1 and temperature T1 to pressure P1. Volume suppose have changed to V2 and temperature has got changed to T2. So, going from this state to this state has followed an isobaric process. Now let me move ahead to isochoric process. Iso means again the same, choric means that the constant volume is to be maintained. So once you are suppose say going from P1, V1, T1 to let's say P2, V1, T2. So where the volume of the system has been kept constant. So that kind of process is known as isochoric process. Having done these three simple kind of processes, we come over to adiabatic process. Now what do we mean by adiabatic process? An adiabatic process basically means any process where the transfer of heat cannot take place between the system and the surrounding. We have discussed this thing, right, that there is a system and the outside is the surrounding. So whenever heat change are taking place between the system and outside the system, that means that kind of processes we are going to study. But suppose if I have maintained a condition, the boundary, the wall I have taken is such a kind of boundary which is non-conducting to heat. That means neither the system can get heat from the surrounding nor the system can give heat to the surrounding. Such processes are known as adiabatic processes. Moving ahead, what do we mean by cyclic process? any process, like where for example you are starting from this condition where pressure is P1, volume is V1, temperature is T1, you move to some other thing where pressure is P2, say volume is V2, temperature is T2. Going to situation number 2, again you are coming back to the previous case. So any process in which the system goes back to the same initial state after it undergoes a series of changes, such kind of processes are termed as cyclic process. Moving ahead, let us talk something about reversible processes. Now let us take into consideration, for example, I am taking any reaction, say A is gonna give B. Or let me say, this A represents the state of the system, state 1, and this B represents state 2. And the very easy example is you take a beaker, you enclose some gaseous substance and you cover it with a piston. So you are trying to move the piston very slowly. Now if you push the piston little down, it will automatically try to come up little in the upward direction. That means any kind of process in which the system always departs infinitesimally from the state of equilibrium. Like for example, the system was very happy in state 1. You push the system a little so that it can go to state 2. But the push is very small. So since the push into the system was very small, the system tries to come back to its initial state. That means at every point there is an equilibrium which has been maintained. If a system is going in a very little step in the forward direction, just a second after it will come back to the previous thing. So such kind of processes where the directions can be reversed at any point of time, these kind of processes are termed as reversible processes. Now since we have discussed what are the different kind of processes which we are going to discuss in thermodynamics, let me come over to another topic which basically deals with thermodynamic properties. Now what do we mean by thermodynamic property? It is basically defined as any measurable or any observable characteristic of the substance when the system remains in equilibrium state. Or I'll simply say, suppose like I am a tutor, so I have been assigned a particular name, I have been assigned a particular subject to teach. That means this is my property, that I am this tutor, my name is this, and I am teaching this subject at this point of time. Similarly, if I consider a system, so to assign what are the different properties of the system, like you need either the pressure of the system, you need to define these few characteristics. Like you should know what is the pressure of the system, you should know what is the temperature, the density, what is the energy or the volume occupied by system. So these things, these measurable or observable characteristics which are basically used to define the property of any system are termed as the properties. Now, since we know what are properties, it will be easy for me to classify the properties so that I can study the same kind of properties in one go and the other kind of properties in another go. For that thing, we have basically characterized properties into two basic categories. The first category is dealing with intensive property. Now, what do we mean by intensive property? Those kind of properties whose value doesn't depend upon the mass of system you have taken. Like for example, if I say this is a room and the temperature of the room is say let's 25 degrees Celsius. Now if I ask you to measure the temperature in this corner of the room, again this is 25 degrees Celsius. If I ask you to measure the temperature of entire room, again you will say it is 25 degrees Celsius. That means any property, like for example, I have taken a beaker which has water and I am saying that water is at let's say 70 degrees Celsius. That means whether you will be taking just a drop of that water, you take a spoon of that water or you take the entire bulk, the temperature of the water will be same. So such kind of properties which do not depend upon the mass of system like temperature, pressure, density, specific volume, these are known as intensive properties. Intensive because these are independent of the mass of the system. They do not change on changing the mass of the system. Further moving ahead, what do we mean by extensive properties? On the similar lines, I can simply say those properties which depend upon the mass of the system. Like for example, the total energy. Quite easy if I talk about the volume. Like for example, I have said 25 grams of water is taken. So if I suppose the density of water to be 1 gram per ml, now this density will be an intensive property. Why so? Because it doesn't depend. Even if you take a drop of water, you take a beaker of water, or you take a sea of water, the density of water is going to be the same. So density is an intensive property, whereas volume will be an extensive property. So supposing density is 1 gram per ml, the volume of water will be 25 ml. Whereas if I simply start with 5 gram of water, we'll end up getting a volume as 5 ml. That means this volume as a property, it depends upon the mass of system, and hence this is known as extensive property. Now we'll be discussing, since we have discussed about pressure volume, since thermodynamics is basically related to heat, so the basic property which we are going to study each and every time is known as temperature. Let me define temperature. The temperature is basically defined as a measure of velocity of fluid particles. Like if a fluid particle is having a large amount of energy, it is going to possess a large amount of kinetic energy, which will be somehow related to the temperature of system. Or I can very easily, in a layman language, say that temperature is that property which is basically used to determine the hotness or the coolness of the body, or the level of heat intensity of the body. So we generally say if a body is quite hot, that means it will be genuinely at a higher temperature. And if a body is very cold, we'll say that the temperature of the body is going to be very less. So this is a basic property. Now coming over to another type of system, which are adiabatic system. I remember we have discussed adiabatic system in the previous slides. Let me once again define adiabatic processes, adiabatic systems. I say that an adiabatic system is one which is thermally insulated or which is thermally isolated from its surrounding. That means if you have a system and the corresponding surrounding, there is not going to be any change or any exchange of heat between the system and the surrounding. It can ever exchange work with the surrounding. So this exchange of work with the surrounding I'll be dealing in the further upcoming slides. So for this time, now it is very clear that adiabatic systems are those where no heat change take place between the system and the surrounding. If it does not, then the system becomes isolated system. Now let us first of all define what do we mean by phase of any system. So a phase is basically that quantity of matter which is homogeneous throughout. For example, I say that water is in liquid phase. That means the entire water, whatever I'll be having in the beaker, all of it will be there in the liquid phase. If I say, for example, water is in solid phase. So solid phase of water is nothing but ice. So we say that if any matter is homogeneous throughout in terms of both the physical structure as well as chemical properties, that is called as a phase of system. Now how the phase of system is further defined, we'll say the systems are classified according to homogeneous or heterogeneous. What do we mean by homogeneous system? A system which consists of a single phase is termed as homogeneous. Homogeneous means same throughout. Now for example, I say that you take a beaker of water and add a few drops of nitric acid. So once you dissolve a few drops of nitric acid into the beaker, the entire new solution you have got is completely homogeneous. That means whether you are taking the drop from this part of the beaker or you are taking drop from this part of the beaker, it is going to have the same composition both in the terms of physical composition and chemical composition. So such systems are called homogeneous systems. Now let us define what do we mean by heterogeneous system. I say that a system which consists of two or more than two phases is called heterogeneous. For example, in this solution of HNO3 aqueous, I ask you to go and put some sand. So you know that the sand is going to settle. If I ask you to put some, let's say, some rocky material, this is going to settle in the lower part of the beaker. That means you can very easily distinguish the solid part from the liquid part. So such kind of complete system is known as heterogeneous system. Now let us come over to what do we mean by thermodynamic equilibrium. I have told you that any process in which both the forward as well as backward directions, these can be achieved with the equal pace. So at that stage, there is said to be equilibrium established. There are following three types of equilibrium states that must be achieved in order for any system to be called in thermodynamic equilibrium. The very first equilibrium which we are going to study about is thermal equilibrium. What do we mean by thermal equilibrium? That means, according to the name it suggests, the temperature of the system doesn't change with time and it has the same value at all the points of the system. Whether you're pushing the piston little down or you're pushing the piston little upside, at any particular stage, the temperature of the system is not going to be changed. So such is called as thermal equilibrium. Coming over to what do we mean by another equilibrium as mechanical equilibrium? There are no unbalanced forces within the system or between the surrounding. That means there is nothing kind of unbalanced force. Everything is quite balanced. If the total number of force, like all the vectors which are into the system, is equal to the vectors outside the system. For example, the pressure in the system is same at all the points and it doesn't change with respect to temperature. So is said to be established and a kind of mechanical equilibrium. Again, the third kind of equilibrium that we are going to study is chemical equilibrium. That means no chemical reaction takes place in the system and the chemical composition is same throughout the system and it doesn't vary with time. So such kind of systems are supposed to have chemical equilibrium. If a system possesses all of these three kinds of equilibrium, the system is said to be in a state of thermal equilibrium. I think this much has been clear to you people. So now if this thing is all clear, let us go for some illustrations. Let's see the very first example. The amount of heat required to raise the temperature of unit mass of gas through 1 degree at constant volume is called what? Okay, so let us say, for example, he has specified the temperature as 200 Kelvin. Now, for example, he says that you need to raise the temperature of a unit mass of gas. For example, I have taken 1 gram of any particular gas and I am enclosing it in a particular container which has got a volume V. So I want to raise, suppose this gas was at 200 Kelvin, I want to raise the temperature of this gas by some value, but the volume has to be maintained constant during the entire process. So whatever is the amount of heat required to bring about such a change is known as specific heat at constant volume. So as per the name suggests, I'll simply say this is a kind of definitions for what do we mean by specific heat at constant volume. So A is the correct option. B option, let us take into consideration, is specific heat at constant pressure. No, but in the question it has been given that it is being carried out at constant volume. So this is wrong. Kilojoules is not, kilojoules is just a unit of heat. It doesn't define like whether the temperature of unit mass of gas is to be increased or what. So this is also not the answer, and of course this fourth option is also not the correct answer. Coming over to second illustration, in an isothermal process, there is no change in enthalpy, there is no change in temperature, all of these, there is no change in internal energy. Now that is very clear that if I am talking about isothermal process, I told you in the beginning, iso means same and thermal means temperature. So isothermal processes are those processes where there is no change in the temperature, and hence I will say B option is the correct one. Students, in this part you had seen that we had discussed something about what were the different kind of processes, isothermal, isochoric, adiabatic and other kind of processes which we are going to deal with in the upcoming chapter. Also I told you something about what do we mean by homogeneous and heterogeneous systems. Now since we have done the basic terms of thermodynamics, the basic type of processes which take place in thermodynamics, now using these all systems and the different kind of processes, in the upcoming sessions I'll try to tell you about how to do the numericals on these chapters. Also, we'll try to come up to what are the different laws of thermodynamics. There were different laws which were given for thermodynamics, and the entire theory of those laws and the questions related to those laws have been discussed in the upcoming sessions. So stay tuned and be there in the next session.